factorize this expression. So, we first check whether there is a common factor among all the four terms of the expression. Well, we see that there is no common factor among all the four terms of the expression. Can we factorize it by grouping? If we take x square common, we have an x plus 3 term left, but here we have 3x plus 1. Even if we rearrange the terms, we'll find that we cannot factorize it by grouping. There is a square term, 1, but then there is no more square term. We have a cubic term, x cube, and also 1 can be written as 1 cube. So we have two terms which are in the form of cube. Now recall this identity. A plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. Another way to write this is a cube plus b cube plus 3ab into a plus b. So if we have an expression containing four terms which has two cube terms, we can check whether the other two terms are of this form. If yes, then we can factorize the expression using a plus b whole cube. So let us come back to this expression. We have already seen that x whole cube is x cube. So we can compare it to a cube. Also we have seen that 1 whole cube is 1. We can compare it to b cube. Now what is 3a square b? We need a 3a square b term. So what is 3a square b? 3 into x whole square into 1. It gives us 3x square. So yes, we have a 3x square term here. We also require a 3ab square term, a 3ab square term. Now a here is x and b here is 1. So 3ab square will be given by 3 into x into 1 whole square, which is 3x. So we do have a 3x term here. So this can be written in this form. So we can write it as x whole cube, 3 into x whole square into 1, 3 into x into 1 whole square plus 1 cube. Compare x to a and 1 to b. So this becomes a plus b whole cube or x plus 1 whole cube. So this is the factorized form of this expression. We can compare it to a cube plus 3a square b plus 3ab square plus b cube and factorize it as a plus b whole cube. So we get x plus 1 whole cube. Now you can even expand it and check, you'll get this expression. Now we have this expression and we need to factorize it. So we have a cube here and a cube here. Also 8 is equal to 2 cube. So we can write it as 2x whole cube plus y whole cube. So we have something of the form a cube plus b cube. Now compare it to this identity. So we have an a cube term and a b cube term. If we can get a 3ab into a plus b term, then we can compare it with this identity and factorize it as a plus b whole cube. So what is 3ab? 3, a is 2x times 2x, b is y times y into a plus b. Into a plus b is given by 2x plus y. So we can write it as 3 into 2, 6, x into y, xy, 6xy into 2x plus y, which is what we have here, 6xy into 2x plus y. So we can write it as 3 into 2x into y into 2x plus y. Now 2x is a and y is b. So a cube plus b cube plus 3ab into a plus b. A cube plus b cube plus 3ab into a plus b. This gives us a plus b whole cube. So this can be written as 2x plus y whole cube. This is the factorized form of this expression. Now factorize this expression. We see that we have a cube term here. This is 3 cube. 125p cube. 125 is the cube of 5. So this is 5p whole cube. But notice that we have a minus sign here. So this is a cube minus b cube minus something plus something. Now recall this identity. This identity is of the form a cube minus b cube minus 3a square b plus 3ab square. So if we can compare the terms of this expression with the right hand side of this identity, we can factorize it using a minus b whole cube. So let us do that. Now 27 is equal to 3 cube. So that is a cube. We can compare it to a cube. 125p cube is 5p whole cube. So we can compare it to b cube. Now we require a 3a square b term to be subtracted and a 3ab square term to be added. So let us find 3a square b. 3a square, a is 3 into b, b is 5p. This is equal to 3 into 3 square, that is 9. 3 into 9 is 27. 27 into 5 is 135. 135p. So this is 3a square b. So we need a minus 3a square b term, that is a minus 135p term, which is here. Now we require a 3ab square term. 3ab is 5p. So 3 into 3 into 5p square. 3 into 3 is 9. 5 square is 25. 9 into 25 is 225 p square. So this can be compared to 3ab square. We require a 3ab square term to be added. That is, we require 225p square to be added, which is what we have here. So now can you factorize this? Now 27 is 3 whole cube minus 125p cube is 5p whole cube minus, we need a minus 3a square b term. So minus 3 into 3 whole square into 5p. This is the same as minus 135p and plus 3ab square. So 3 into 3 into 5p whole square. This will give us 225p square. So we have this in the form of the right hand side of this identity. Now 3 is a and 5p is b. So compare 3 to a and 5p to b. And now we can write it as a minus b whole cube. That is 3 minus 5p whole cube. This is the factorized form of this expression. You can expand it and verify that once you expand it, you'll get this very expression. Now factorize this expression. Again, recall this identity. We have something cube minus something cube 216 is the cube of 6. So 1 by 216 is the cube of 1 by 6. 27p cube is equal to 3p whole cube. It is the same as a cube. 1 by 216 is equal to 1 by 6 whole cube. It can be compared to b cube. So we have a cube minus b cube. We have already got these two terms. Now we need a minus 3a square b. So first let us check what do we have as 3a square b. 3a is 3p and b is 1 by 6. So 3 into 3p whole square into 1 by 6. So we can cancel out this 3 and 6. We get 9p square by 2. And this term has to be subtracted. So 9p square by 2 term is subtracted. So we have got this. We require a plus 3ab square. So plus 3ab square is 3 into a is 3b. b square is 1 by 6 whole square. Now we can write it as 9p divided by 6 into 6. We can cancel out 3, get 2. Cancel out 3, get 2. So this gives us p by 4. So we have a p by 4 term. That means we have this. So this can be written as 3p whole cube minus 1 by 6 whole cube minus 3a square b, that is 3p whole square into 1 by 6 plus 3ab square. 3p into 1 by 6 whole square. This is what we have. Now we can write it as a minus b whole cube. So 3p minus 1 by 6 whole cube. This is the factorized form of this expression.